Our wise guy, U of I physics professor Matt Sellon is here. And Matt, everyone's got Christmas tree lights. Well, most folks have Christmas tree lights up, but there's some new cool ones out, the LED ones.
Oh, that's right. And so I wanted to describe how an LED works, because you can buy now, really for the first time, affordably, Christmas tree lights or holiday lights that are made with LEDs. And they have the advantage that they're cold. They don't use a lot of power just heating things up. They don't waste energy at all, so they're very energy efficient, and they last for basically forever.
Oh, wow.
And so what I want to do is describe how a diode works.
Okay.
And there's a real Illinois connection here, I got to say, because the condensed matter physics and development of semiconductor devices has a very long history at Illinois. John Bardeen got the Nobel Prize. He was a professor here. In fact, he got 2 Nobel Prizes. One was for development of the transistor and explaining how that works. Oh. And the LED was developed by Nick Holniak, who is a professor here. Okay, so Illinois, we should be very proud of this. Okay, so that's why I have the Illini colors on my model of the diode. Okay, so
right on it.
Right. So what I'm going to do first here is I'm going to describe to you. Well, we have to let these little mini marshmallows are going to be electrons.
Okay.
Okay. And so these will represent a battery. So the side of the battery with a bunch of marshmallows in it is the negative side. The side without any marshmallows is the positive side.
Got it.
Okay. And this piece of wood is going to represent. Now it's turned, actually. Upside down, so this is just going to represent a piece of wire, not a semiconductor or anything like that, just a regular piece of wire. Okay, and we know that like sign charges repel. So if you attach a battery to a wire that has a bunch of electrons, the electrons over here will push these guys over this way, so they'll all kind of meander this way. The electrons will come out of the battery, they'll go into that end of the battery, they just flow. Okay,
right. That's how a battery works.
That's how a battery works, and that's how a wire works, because the electrons are free to flow.
Okay.
Okay, now in a semiconductor, which is made of silicon, things are not quite as simple as that. The electrons are not completely free to flow. And actually, a piece of silicon, if you don't do anything to it, is a rather lousy conductor of electricity. It's like a piece of glass. It's a very bad conductor, okay? So what I'm going to do is I'm going to represent, this piece of wood is going to represent a piece of silicon. And I'm going to put some electrons in it. And then what people do is they do something called doping, which is that on one side of the semiconductor, they will add some atoms which donate electrons. So you have maybe an extra electron over on this side. Okay, because the atom underneath it has an extra positive charge too. And over here you'll add, so this was a p-side or a p-type semiconductor. On this side you'll make an n-type, I'm sorry, this is the n-type, it has an extra electron. On this side you'll add some material that takes away an extra electron, okay? So you have fewer electrons over here that can move around. Here you have more that can move around.
All right.
Okay? And you can notice that the absence of an electron can act like a positive thing, because what if I do the following? What if I put a battery and I hook it up this way, so I have a positive end of a battery. I'm sorry, I'm going to do it this way. No, negative end of the battery over here, positive end over here.
You're playing the shell game there for a second.
Yeah, you have to guess which one's which. Okay, so now all these guys will tend to drive this electron over to here.
Okay.
Okay, this guy, they will tend to drive also these electrons this way. This positive one will tend to drive this empty spot over this way. Okay, these guys, they can just sort of jump from place to place, and you end up with an empty spot there, and you have an extra one there. Whenever at this junction port you have an empty spot on one side and an extra guy on the other side, he can jump across.
Wow.
And you have conduction. Okay.
Very cool.
Now, suppose you started with it just the way I had it before.
We have 30 seconds, Matt.
And the battery is hooked up the other way.
Got it.
Now, you have basically nothing happens, because these guys push these electrons over this way.
Right.
Over here, you can't pull this guy away from here, so there's no place he can go.
Nowhere to go.
So you can't get conduction, okay, because there's no empty spot on either side of this little line. Okay, so diodes are one-way devices, and so the way the Christmas lights work, okay, oh, by the way that these things give away light is that when you have the thing hooked up this way, and this guy hops into this empty spot, that's when the little flash of light comes out, okay?
Very good.
And when these guys, if you jiggle them back and forth...
I'm going to go kill the lights so you can see this.
Okay, you should. Yeah,
We're going to go a little over time here, but this is pretty cool.
Kill the lights. If I spin this thing around, notice how they leave little streaks but not a solid streak?
Yeah.
Okay, so these little guys are flashing. It's because the diodes only conduct and emit light on one phase of the 60 hertz electricity. On the other phase, they're off. So that's why they look like they flash a little bit.
All right, very good. Well, speaking of off, we're off our time. Time
sorry.
for Jennifer. No, it's okay.
I always do that.
Well, that's okay. We'll have more in 30 minutes with Matt.
Yes,
Jennifer, you're up.
Lots more.
Thanks, Rob. Well, it is just a little